This is Josh White with JW Math Tutoring. In today's video, I'm going to cover Digital SAT Bluebook Practice Test 8, the Math section Module 2B, the harder of the two second modules. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Just before I begin going through the solutions to Digital SAT Bluebook Practice Test 8, Module 2B, the harder of the two second modules, please keep the following things in mind. First, this video may run past the allotted 35 minutes that you have to complete this section. So just be aware that's because in some problems I will show multiple methods to solve the problems. Okay. So just be aware that that's only happening because on some of these I'm showing like 3 or even 4 different ways possibly to solve the problem. Whereas if you were taking this test, as an official exam, you would not need to demonstrate all those methods. Second, of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And third, if you haven't done so already, of course, please check out the solutions to the same Practice Test 8 Module 1. And once it's posted, the solutions to Module 2A, the easier of the 2 second modules as well. All right, so with that said, let's go ahead and get started. Question number 1. Here you have an equation, and they want to know which solution has which equation has the same solution as this one. So all you're doing here is just doing -6, and you get 4x equals 12. You don't need to go any further than that. The correct answer for this is just letter C, and we can move on to the next problem. All right, next up, here they give you a function um, where tell you that you lease a car for 36 months, and X is how much you pay each month, and they want to know how much you're going to pay in total if your monthly payment is $400. So this is just basically doing 36 times 400 plus 1,000. If you can go to Desmos obviously and do this out, if you don't know what this is in your head, but I'll just tell you this is going to be 14,400 and this is another 1,000, so the total cost is going to be $15,400. It is letter C for the correct answer. We can move on to the next problem. Next up, we have a line given in standard form, and they want to know what the y-intercept of the graph will be after you shift this down 5 units. So what I think is the easiest way to do this, quickest way, is find the y-intercept of this line by just plugging in 0 for x. And then, so this whole thing becomes 0. You just divide by 33. This, you're just going to get y equals 9. You can just obviously do this in Desmos if you don't know it off the top of your head. And then all you have to do is shift it down 5 units. So if the y-intercept is at 0, 9, when you shift it down 5 units, it's now going to be at 4, or as a point, 0, 4. So the correct answer is just going to be letter A. Now, you could do this in Desmos as well. And basically, all we're going to do is just the same thing, except that instead of doing the actual work, I'm just going to graph it. And I'm going to say, okay, it's at 0, 9. If I shift it down 5 units, now it's going to be at 0, 4. Okay, and that's it. So maybe you find that quicker than just, plugging in 0 for x, dividing by 33, and then subtracting 5. Either way, correct answer is letter A. Next up, question number 4, they give you this function and they want to know what the y-intercept is. All we have to do is notice this is already in y equals mx plus b, or slope-intercept form. So right here, excuse me, -2 is going to be equal to b, or the y-intercept value. So the correct answer for this is just going to be letter B. Now, of course, if you didn't notice that, you could just go to Desmos and you could graph it out. And then you could just find the y-intercept point on the graph here, 0, -2, and get it that way. Okay? But anyways, regardless of whichever method you choose, correct answer is B. Next up, you have a graph of like 2 companies showing shares of stock, the relationship between them in terms of how many this person could purchase. Uh, and basically, they want the linear equation that describes this situation. So if you're going to do this by hand, I'll show the Desmos solution a little bit, but to do this by hand, the easiest way I like to think of this is look at the intercept values. So for example, here it's the y-intercept is 0, 40, and then for the x-intercept, it's down here 60, comma 0. And just go through these equations and see which equation has the same intercepts. So right off the bat in A, the y-intercept is 12. This is y, this is x, okay? So that one's out. In B, the y-intercept is going to be 480 divided by 12. That is going to be 40, so that checks. And then you could also do the x-intercept, which is going to be, this goes, 0 goes in for this, so that term's gone. 480 divided by 8, which is 60, so that checks. So this is going to be the correct answer, and you could just verify this, C, the y-intercept is 8, which is not 40. Obviously, that's wrong. Same thing with D, the y-intercept, these are going to be reversed. The y-intercept is going to be 60 in D, and the x-intercept is going to be 40, which is the opposite of what we have. So the correct answer for this one is going to be letter B. Now, you can go to Desmos, and basically what you would do is you would graph out the lines. You would see, first of all, does the line look like what we have up here, and does it have the same intercepts? Okay, for A, the answer is obviously no. For C, the answer is obviously no. They don't even have the right slope. For B, now you have to zoom out a little bit here. Here you see 40, yep, and here you see 60, so that matches. And notice for D, you change this to 12 and change this to 8. You now get 60 for y and 40 for x, but that's not what we want. That's the opposite. So that just confirms that that is incorrect. Next up, we have number 6. So in this question, they have a system of equations. They want to know what the value is. 17 over 2x plus 18y, where x and y are the solution to this system of equations. So, excuse me. There are, okay, if you're going to do this by hand, I'll just show you. The quickest way to do this is you take the second equation and you multiply everything by 2. The reason you do that is because then you're actually able to add the two equations together and get the exact expression they're looking for. Because 7 halves x plus 10 halves x is 17 halves x. 6 plus 12, 6 is 18y. And then 25 plus 46 is 71. Okay, so the correct answer is going to be D. However, that's not obvious to everyone. So instead, let's go into Desmos and see how I can do this in Desmos. So your natural instinct would probably be just to type each equation, then get the xy value. All right, here we go. So where is the intersection point? All right, looks like it's right here at 2, 3. So I'm just going to export that, and then I'm going to delete the parentheses. I'm just going to do 17 over 2 times 2 plus 18 times 3. Right there, the answer is 71, and that's it. Again, that's how you can do it in Desmos. Probably much quicker than the method I showed of doing it by hand. Next up, question number 7. Let me see if I can zoom out on this so we can get all the answer choices on the screen here. All right, so you have this polynomial function, and they want to know which of the table of values represents the f of x minus 3. So in other words, this function but shifted down 3. That's what you're checking these tables of values against. All right. So here's the thing. If you notice, all of these x values, which are -6, -5, and 4, these are just the zeros of the function. Meaning, when you plug in either -6 or -5 or 4, one of these parentheses turns into 0, which makes the whole thing equal 0. So for the function, all of these are going to be negative 6, 0, negative 5, 0, and 4, 0, which means that when you shift the function down 3 units, these will all then go to negative 3. So all we're looking for is something, a table of values which has y's for negative 3 for all of these. The correct answer here is going to be letter B. Now, you could, of course, go do this in Desmos. And delete all this. So we put in the original function. Then I'm going to do the translation. Okay, so shift it down 3 units. Let's get rid of the original. We don't want that. Okay, so now what you could do is you could just go through and say, okay, in this new function, what is g of negative 6 equal to? Well, it's negative 3. So that means A and D are out. Those have negative 9 and positive 3. So these two are gone. Then you just have to pick one of the other values to check. So if you check g of negative 5, it's also negative 3. Okay, that confirms that it's letter B and not letter C. Okay, so that's how you could do the entire thing in Desmos, and it doesn't take that much longer than the approach I took by hand. Next up, we have question number 8, an exponential function. So actually, let me go back to the standard zoom view here. By the way, control plus 0 if you need to get back to the default, kind of zoom or viewing zoom level. All right, so if you're increasing x by 1 and it's causing the q of x or the y to decrease by 45%, that is basically meaning that you're going to multiply by 0.55. So, and the initial value is 14. That's what the q of 0 means here. Initial value, starting value is 14. So that means there's going to be a 14 in front. So the correct answer for this one is going to be letter C. Now, just to briefly review how we know it's 0.45, 0.55 as the base here, which corresponds to a 45% decrease. Think about if you start with 100, okay? And so you take 45% of that, 0.45 times 100, okay? And that's just the number 45. If you take that and you decrease your starting value of 100 by it, you're left with 55. So notice I started with 100, I ended with 55. Now, I could also get there by just doing 100 times 0.55. So notice that 0.55 corresponds to a 45% decrease. That's why it has to be 0.55 inside the parentheses here. Really, when you do an exponential growth or decay or decline or decrease, it's like 1 plus or minus r. In this case, since it's decrease, it's 1 minus r, and the r is the 0.55. So that's really what simplifies. The r is 0.45, excuse me. So that's what makes the number inside the parentheses simplify to 0.55. Next up, question number 9. So for this one, I have a quadratic function. It's actually given in intercept form. It wants to know how many minutes after collecting the sample did it take for the submersible to reach the surface? So the surface has a depth of 0, because if you're at the surface, you are 0 meters, below the surface. So in other words, this is basically asking, what's the value of x when this function is, what value of x you plug in to get this function equal to 0? Well, there's either two answers. It's either negative 19 or it's positive 35. And we don't talk about time in terms of negative minutes, so get rid of that. So basically the correct answer is just 35. And again, you could, if you were confused by the wording or whatever, right, you could just go to Desmos and you could just graph it out. But you do have to know that to reach the surface means have a y value of 0. And so the point we're looking at is right here, 35, 0. So it's just 35 minutes. That's it. We can move on to the next question. All right, number 10. This is, it looks like a fairly complicated problem, but it's actually not that bad. Essentially, what you have going on here is you have a cube, and the cube has every side with a length of 68. All right, and then inside of it, there's a sphere. And the sphere, let me see if I can pick a different color here. The sphere has a radius of 34, and it basically is like touching each face on the cube. It's kind of like the sphere is tangent to each face of the cube, if you want to think about it that way. So this is not going to be a great picture, but you have the sphere kind of inside here, touching each face of the cube. You could also like draw a thing kind of like that direction as well. Okay, and they said you have its thing here, 34, its radius. All right, they want to know what's the volume of kind of like the area outside of the sphere and inside of the cube. So like visually it look kind of like this. And there's other stuff you can't see, just, this is not a great 3D picture, but all you're doing is finding the volume of the cube, which is just going to be length times width times height, or 68 cubed, 68, times itself 3 times. That's going to be 314,432. And then the volume of the sphere, which is 4/3 pi r cubed. Note, if you do not remember that formula, click the reference sheet, and it is right down here. Again, volume 4/3 pi r cubed. So it's going to be 4/3 times pi times 34 cubed. And what I can actually do now in Desmos, I can just do the whole thing in one step. So this is my cube volume, and then I'm going to subtract 4/3 pi 34 cubed. Okay, what do I get? 149,795.789. Okay, that is clearly closest to letter A, the 149,796. So the correct answer for this one is just going to be letter A. Next up, they want to know what the sum of the solutions to this equation is. So first I will show you how I would do this by hand. Would multiply out the left side, distribution property basically. I would do the same thing to the right side. Then I would get all the terms on one side, so I'm going to subtract everything over to the right. So I get 0 equals, to make the x squared term positive, 3x squared minus 29x plus 56. Yep. Now, you could factor this, or and then like get each of the solutions and then add them together, but there's no reason to do that. We're just going to use the shortcut formula, which is negative b over a. So the sum of the solutions is the opposite of negative 29 over 3. That just becomes positive 29 over 3. Or again, you could enter it as 9.666 or 9.667 if you round it versus first number is truncating the decimal. So I'm going to put in just 29 over 3, but again, you could enter either of those decimals as well. Of course, if you wanted to do this in Desmos, that is always an option. And we graph y equals left side and y equals right side. The only problem, it's like a little tricky to see exactly where they intersect at. So one of them is right here. And the other one actually is this intercept right here. So essentially what you would be doing to get the sum of solutions is you'd be adding 7.26667. And at this point, again, you would put in 9.666 or 9.667 to get your answer. Okay. Or again, we could also, I guess, let's just double check if we do it this way, it might be easier. Yeah, here it's actually probably quicker to just type it in this case all as one thing. You get here, you easily see your two values, just add those together and get your answer. All right, next up, we have another one where I have to zoom out to get all the answer choices on the screen because we have a table of values. So y is less than 6x plus 2. Honestly, with these, I think it's just so much easier to go straight to Desmos and just graph it out rather than trying to go through and like plugging all the point, every single thing in. So let's start with A, 3 comma 20. Is that a solution? So it's on the line, it's right on the border, but because it's less than, it's not less than or equal to, but strictly less than, it is not a solution. Okay? So basically you're going to get 20 less than 20, which is false. All right, so that means for B, if we just change this to 16 now, yes, that one does work. Okay, let's check 536. Just scroll out. Okay, notice this one does not work. This one is outside the solution set. Okay, so we can move on from there. For C, we already checked that one. We already know that one works. Now let's check 528. Okay, that one does work. And lastly, let's check 740. Either it works and that's the answer, or it doesn't work. Okay, so all 3 points work. So the correct answer is going to be C here. Again, that's the quickest way that I find to do these. Is just go to Desmos, type graph the inequality, type in the points, and just see are they part of the solution set or not. But again, correct answer is C. Next, relatively, let me again control 0. All right, what's going on here? Why is it not letting me? There we go. Zoom back to the standard default zoom view. All right, what's the diameter of this circle? Well, we know standard form that the right side is equal to r squared. So that's 16, which means when you square root it, you get r is equal to 4. The diameter is twice the radius, so 2 times 4 is just 8. Correct answer to this problem is just 8. That's it. Also, if you weren't sure, you could, of course, go to Desmos and you could graph it. And then, I mean, this you should be able to look at and count. Notice it's going from 7 to -1. But if you just wanted to be extra sure, you could do the distance formula between the 2 points, and that gives you 8. And because I used 2 endpoints here, like that is the value of the diameter. So that just gives me the answer that I'm looking for right away. Next up, question number 14. Here we have a quadratic, and there's only one solution. So what is the value of C going to be? So there's 2 ways to look at this. One way, I'm talking about doing this by hand. I'll go to show you in the Desmos method in a second. So one way is just to leave it as it is and look at b squared minus 4ac. Basically, you set that equal to 0. So we got 30 squared minus 4 times -9 times c. 900 plus 36c equals 0. 36c equals -900. C is going to equal -25. Now, that's if you want to solve it out by hand. You could also look at completing the square. I don't know it's necessarily going to be faster. I mean, first of all, if I was going to do that, I would like switch the signs of everything. I just multiply everything by -1. So I'd make it 9x squared minus 30x minus c equals 0. And then I'd notice, let's see, it's going to be the same parenthesis twice. So it's going to be 3x and 3x. And then since the middle number, the b value is 30, or technically -30 here, it's going to have to be the same number that adds up to -30 twice, meaning it's going to have to be -15 plus -15 because we're basically looking for the same parenthesis twice. So then it's going to have to be, what do we do? What do we multiply by 3 to get -15? Well, it's going to have to be 5. So it's going to have to be -5 minus 5. That means that this is going to really be positive 25. So in other words, This negative c term has to equal positive 25, or in other words, dividing by -1, c has to equal -25. Again, if you don't follow that or didn't understand that, that's totally fine. That's just like thinking about this through the process of completing the square. Now, of course, because this is multiple choice, you could go to Desmos and literally just type in the graph, add the slider for C, and move it to all the answers. Okay, is there one solution? No, there are not, because this one has two x-intercepts. Number of x-intercepts is the number of solutions. Obviously wrong. There it is, one solution right here. That's our correct answer. You don't need to do any more work. All right, next up, we have a question with a right triangle and some basic trig. So let me just look at my notes here. The right angle is y. I'll put x up here, z down here. Z is 33 degrees. YZ is 26 units. Okay, they tell us that the area of this triangle, so remember area is 1/2 base times height, is equal to k tan 33. So basically what we're going to do here is I'm going to substitute in the base. I'm going to use my base as YZ, which is 26. For my height, I am going to use the side XY. Just clear this up a little bit. Okay, now that's equal to K, and now for tan 33, I'm going to plug in what that's equal to. So it's going to be opposite, which is XY, over adjacent, which is 26. So now what happens when I go to simplify this? First of all, the XYs are going to cancel out. Next, I'm going to multiply by 26. So K is going to be equal to basically, first of all, 1/2 into 26 also becomes 13. So K is really just going to equal 26 times 13, which is going to be 338. Okay, so that's all you have to do for this problem. It doesn't matter what xy is. You don't actually have to find the value of it. I mean, technically you can, but you don't need to because it cancels out on both sides. And therefore, correct answer is going to be 338. Next up, we have a question dealing with the basically discounting the price of a shirt. So we start at 1170, and the sale price is 80% less than this. So we're going to take away, 0.8 times 1170. When you do that, and you can just go do that in Desmos, you should get the sale price equal to 234. So let's just confirm that. Okay, I'm going to call this S for the sales price, 234. Now, here's the thing that's tricky. The sale price is 30% greater than the cost. So the way you have to set up the equation, the way you have to think about this is the cost of the shirt, C, 30% more than that, i.e. the cost plus 30% of the cost is what's equal to the 234. Or in other words, 1.3 times the cost is what is equal to the 234. So the way you find the cost is just dividing the 2.34 by 1.3. That's going to come out to $1.80. Okay. So again, a lot of people will take the 234 and they try to take 30% of that and subtract it from it, but that's not how it's working. It's actually like starting at the cost and adding 30% to get 234. It is not starting at 234, taking 30% less than that and getting down equal to the cost price. So those two are not the same. So you have to set it up and solve it this way. So you can type in 1.80 for the answer. Next up, question 17, we have some triangles. Aren't necessarily right triangles, but whatever, I'll draw them looking kind of like them. So ABC and DEF. B and E are each 27, so we have one pair of angles. C and F are 41, so we have a second pair of congruent angles. Which additional piece of information is sufficient to determine whether the two triangles are congruent? Okay, so the answer is going to be C, because the methods you can use to prove triangles congruent when you have two pairs of angles are either AAS or ASA. That means we need to have at least one pair of congruent sides between them. Like A and B are only giving us, they're giving us the measure of one angle in A. So, okay, I mean, first of all, we already know what the measure has to be here because it adds up to 180. And that would be congruent to D, but that would not prove the two triangles congruent. That only proves them similar. And then, so that's out. And then if you look at B, if you know the length of this is 10, well, you still need to know what the length of DE is in order to prove that the triangles are similar. So just knowing the length of one side is not sufficient. However, if we know that BC and EF either are congruent or not, I mean, if this is 10 and this is 10, they're congruent, whereas if one is 10 and one is 6, they are not congruent. I mean, they would be similar, but they would not be congruent. But you could, the point is you could definitively prove it at that point. Um, that's why the answer has to be C, because basically then either you're going to use ASA to either say yes, they are congruent, or no, they are not congruent. And obviously D is wrong because you're only given two pairs of angles. That's not enough to prove congruency. All right, next up, we have system equations with a constant problem. And for these, I think the fastest method is to just go ahead um, and just do it out by hand. Because here they want the system to have no solution, so that means we need the same slope but different intercepts. So on the top one, I'm going to add 72y to both sides and subtract 24. So on the right side, I get 102y. Left side, I get 48x minus 24. And then when you divide it, divide everything by 102, you get 8 over 17x minus 24 over 102 equals y. So the slope of this line is 8 over 17. Again, 48 over 102 just simplifies. You divide each thing by 6. All right, now on the bottom one, all we have to do is divide by r. So y equals, and I'm just going to flip the order, negative 16 over rx plus 1 over 6r. And now we set the slope here is negative 16 over r, so we set that equal to the negative 8 over 17. Now you can just solve this by cross multiplying, or you could go to Desmos, and you're going to get 8r equals negative 272. Divide by 8, r is going to equal negative 34. Now, again, I wouldn't recommend doing this in Desmos, like without any of the work, because when it's no solution, the two lines are parallel. But it's very, very difficult to tell exactly when two lines are parallel in Desmos. Like, if you graphed these and you made r like negative 33.9, they would still look parallel. Or negative 34.1, they would also look parallel, even though technically they are not. They would intersect at some point. So that's why I like doing this by hand. And then if you want to check, you can go to Desmos, plug in the R value, and look at the picture and basically see, do they look parallel? And these ones will. So you could use it to check it, but I would not recommend it just for the entire solving of the problem. All right, next up. Here we have a problem that I actually did a previous video on, and in that video I went through 4 different methods, I think it was, to solve this problem. So I'm not going to do all 4 here. I'm just basically going to show what I think is the easiest one, and that is if you look at factoring, these expressions, right? They're going to have to be 3x and x, and we know that x plus 2b is a factor. So now, and here's the other thing. We know that 7 has to go here because the last term is 14b, and the only way you can make 14b is 7 times 2b. All right? So we know that this problem has to be 3x plus 7 times x plus 2b. So now the question becomes, when you multiply this out, like which of these things um, can you make or can you form if b is a positive integer? So notice you FOIL it out, right? 3x squared plus the outer, 6xb plus the inner, 7x plus the last, 14b. So basically what you're saying is, okay, just looking at the coefficients, 6b plus 7, that's the combination of the two x terms, right? So you're basically now going through and saying, okay, what if this equals 7? What is b? If it equals 28, what is b? If it equals 42, if it equals 49. And if you notice, in the first one, like, so if you subtract 7 from all these, because that's how you get it to cancel out, then it becomes 0, 21, 35, and 42. So now you've got 6b equal to either 0, 21, 35, or 42. So the b values are going to be either 0, 21 over 6, 35 over 6, or 7. So in which of these is b a positive integer? It's only the last one. It's only d. 0 is not positive. 21 over 6, 35 over 6, not integers. The last one, again, is d. So again, if you want alternate methods, check out the video I made. You'll see the thumbnail for it come up on the screen, right now to show you other possible methods for it. But I think this is the quickest and easiest method for this problem. Next up, we have question number 20. Here we have an equilateral triangle. Now, we know its perimeter is 624. So we can divide that by 3 and figure out that each side has to be 208 because it's equilateral. All the sides are the same. They want to know the height of this triangle, or specifically like it's something root 3. They want to know what the something in front of the root 3 is. So if you drop the height down, okay, this is a 60. It's equilateral. This is 60. It's going to split it into two 30, 60, 90s. And specifically, this 208 is going to be split up to 104 and 104 because you basically have two congruent triangles on either side. So notice, to get the height here, you could either use Pythagorean theorem or you could do, if you know your 30, 60, 90 specified triangle rules, you could notice that the 104 is across from the 30. It's the short leg down here. The long leg will be equal to 104 root 3. And the height, they said, is equal to k root 3. Therefore, the k value here is equal to 104. Okay, so that's the correct answer, just 104. Now, I will show you in Desmos. So let's say you wanted to use Pythagorean theorem, right? So what I would do is I would just say 104 squared plus, actually I would do it this way. So they tell you it's k root 3, right? So I would say 104 squared plus the height k root 3 squared, and then I'm going to do regression 208 squared. And right there, that's how you can get the k value if you don't know the 30, 60, 90 special triangle formula. It's just using Pythagorean theorem, okay, by using regression. Next up, we have a problem involving two data sets. Basically, they want to know what's the smallest possible difference between the mean of each of these. Okay, so I'll just tell you right off the bat, the answer is B, it's 1. The trick to this one, or the way this one works, is in data set A, you put every value at like the bottom or the left edge of the bar. So in other words, you would start off with like 20, 20, 20, the three smallest values you could have between 20 and 30, 20 and 29. And then next would be like 30, 30, 30, 30, dot, 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 all the way up to 50. And then for B, you do the opposite. So it's like you start off at the high end, which would technically be 19, 19, 19, and then 29, 29, 29, 29, and you do that all the way up. And you notice the difference between every single value is 1. Okay? So it's like the difference between each thing is 1. So you add up 1 like 23 times, and then you divide it by 23, and you just get 23 over 23, which is just 1, and that's it. And that's pretty much the only way to think about it or to, to do it or to figure it out. All right, last up, we have a problem where they give you a sample of votes and then they tell you the total number of votes and they want to know, and this is where it makes this a little tricky, by how many votes would this person be expected to win out of the total number of votes? So, not how many votes Cruz gets or Smith gets, but what is the difference between them? So, there's two ways to think about this. The shortest, easiest way is to say, okay, the difference in votes currently is 163. So the difference is 163 out of 803. Okay, so this is difference and this is total. And then we set up a proportion and we say, okay, well, if the total is 6424, what would the difference be? So we just solve this, go to Desmos, cross multiply it. You should get 1304. And I'm just going to confirm. It's basically going to be 6424 times 163 divided by 803. Yep, 1304. So that's your answer, letter B, and, and then you're done. That's the fastest, quickest, easiest way. Now, the alternate way of doing this would basically be to figure out, it would be to split up the 6424, find how many votes each would get out of that total, and then like go from there to subtract and find the difference. So I'll just confirm that we're still going to get the same answer. So what I would do is I would say, okay, first person, Cruz, 483 out of 803. That's percentage of votes. Let's multiply that by 6424. Okay, so that's Cruz's total. Smith's total is 320 divided by out of the 803 out of the sample, and then times again 6424. Okay, so what's the difference now of Cruz minus Smith? Well, it's 1304. All right, you can see it's much quicker. We're just doing it all in the calculator rather than writing it up by hand. But we get the same answer. So again, it's letter B for this one. All right, so I hope you enjoyed these solutions to Digital Practice Test 8 from the Bluebook app, Module 2B, the harder of the 2 second modules. If you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you have comments or alternate solution methods, please do feel free to leave them, in the comment section below. Um, as I mentioned before, please check out the videos on the same Practice Test 8, but Module 1. And also the solutions to Practice Test 8 Module 2A, the easier of the two second modules. And also for 19, here's the video, just to show you a thumbnail for it, of the video that has like 4 or 5 different, alternate solution methods to that problem as well.